Hey everyone, Wazoo here, and in this video we're going to tackle the most asked question probably in Spring Boot server development, which is how do I set up JWT authentication? That's right, the time has finally come. This video is going to be dedicated to answering that question, and hopefully by the end of it you'll have all the information you need on understanding what JWT is and how to work with it in Spring Boot server. This video is probably going to have a long runtime. I haven't timed it yet. So I've made chapter markers down below. Be sure to make use of them as we go through the different sections of setting up and configuring JWT. If you want to see more videos like this, then I'm just going to admit it straight up front. Like this video, subscribe to the channel, leave a comment down below on if this worked for you or not and what I can do to improve videos like this in the future. So the plan is to go through a higher level explanation of what JWT is, and then we'll take a project from start.spring.io and build up some JWT support. Finally, we'll be able to verify the API endpoints we create with the help of Postman. In this video, we're going to be only focusing on Java Spring Boot and server-side handling of JWT tokens. I'm not planning on going through any client-side JavaScript or any other language frameworks for making use of those JWT tokens. If you want to see a particular framework, please mention it in the comments down below. I can imagine that I'll be putting a video together for both React and Angular. Okay. It's time to grab your favorite beverage and let's get going. Okay, so I made some diagrams to hopefully help illustrate what happens with JWT. So first of all, what is it? JWT is short for JSON Web Token. It is a string of JavaScript that is transmitted back and forth from the browser to the server, which contains 3 pieces of data. You'll see here a sample JWT token. It looks like a bunch of data with a period, another bunch of data with a period, and the last bit of data. So a JWT token is composed of 3 elements. The first element is the header, and this usually defines what kind of signing algorithm is used for the creation of the JWT from the server. Usually it's something like RSA or HMAC SHA-256, but there's a bunch of algorithms you can choose depending on your security level preference. The payload contains the claims that are stored in the token. Now, it's not a good idea to put anything inside the payload, such as sensitive passwords or things of that nature. This is not a secure token format in terms of being able to obfuscate or mask things like passwords. But for the most part, you would be storing things like the user email or username, basic data information such as that. And then finally, in the last section of the JWT is the signature. So this is a string of data that is then used to verify that nothing tampered with the JWT token as it's going back and forth between the client and the server. Okay, so we're going to be basically handling 3 different cases of working with JWT tokens. We'll go through some architecture diagrams here to help illustrate the 3 cases that we're going to be going after in our server-side API here. So the first up is the sign-up process. So this is where the user sends their sign-up information to the server, and then their data is stored in the user repository into the backend, then passed through what we're going to be calling the JWT service, which will then create the token that is sent back to the user, assuming everything went okay during this part of the process. The sign-in process is a lot more involved than just signing up to the server, because now you're throwing in authentication along with generating the token. So the user will send in their credentials into the server. The authentication manager will then grab those credentials and attempt to authenticate the given account and password. And if that authentication fails, then it returns a 403 error code back to the client. If it succeeds, then it moves on to retrieving the user from the user repository data store and then applying the same JWT service token generation methods that we used during signup. If the user is not found, then it also returns a 403 back to the client. If the user is found, then we apply the same logic that we used during the signup flow in order to create a JWT token that we then return back to the client with an HTTP 200 status. Lastly, we have the process of requesting a resource. So this is communicating with any controller in your server that is governed by Spring Security and JWT. So once we've authenticated, we've logged in, we've received the token, we then retransmit it when we want to make another call back to the server. And so it will then pass through what we're going to be calling the JWT Authentication which is a security filter that handles, this is a security filter that runs once per request to the server. If we're missing the JWT from the headers in the request, then we return with a HTTP 403. We then move to the JWT service to extract the JWT token from the header and retrieve the user from our user repository. So if that user does not exist or there's missing information from the JWT payload, then it also returns a HTTP 403 back to the client. If we succeed in finding the user, we then validate the JWT, then go through the context security holder. Finally, we then pass through there and continue on to the requested controller endpoint or whatever resource that we were requesting. And assuming that that request succeeds, it will then return the expected HTTP 200 along with the resource in the payload back to the client. So there's quite a few pieces to go through here. I went through it. I hope I didn't go through it too quickly in these flow diagram overviews. But now let's go tackle some code and hopefully it'll match up with what we went through in these diagrams. Okay, so as usual, we go to start.spring.io. We're going to be creating a Maven project using the Java language and the Spring Boot 3.1.2 in this video. For our group name, we can leave it as com.example. And then for our artifact name, I just used Spring Boot 3 JWT Authentication Server. Okay, we want to keep it as a jar file. We want to keep it using Java 17. And let's go ahead and add some dependencies. Okay, so as you can see here, I've added the Spring Boot Dev Tools, the Docker Compose support, Spring Web, Spring Data JPA, the MySQL driver, Spring Security, and Lombok. That should be all we need. Just hit the generate button and download the zip file and extract it to your favorite place on your machine. Okay, so as you can see, we've opened up the project in IntelliJ. And what we're going to be doing is first set up our Docker Compose container. So we've got a compose.yaml file. Let's go ahead and open that. And we're going to empty everything out here and start fresh. We're going to be using version 3.8. And then we're going to be creating a services section along with a database image. So we're going to be using the latest MySQL image. We'll set the restart flag to unless stopped. We'll be making use of a .env environment file, and we'll then be pulling in these environment variables from that env file. We'll be using ports 3306 mapped to 3306 internally to the image, and we'll be saving the data in a volume/var/lib/db and making use of the Spring network, which is just our own network. Next up, we're going to be creating a PHP myadmin image, which depends on the database image. We'll be making use of the PHP myadmin/PHP myadmin Docker image. Same flag, restart unless stopped. We'll be exposing port 8081, which will be mapped internally to the image to port 80. We'll be making use of the .env file again and the MySQL root password from this .env file, and we'll be using the same network, Spring network. Finally, we'll be defining a volume of DB data, and then for our networks, we'll be using the Spring-network that we've been mentioning in our image definitions above here. Okay, so let's go ahead and create the .env file. So new file right in the root of our project. We'll use .env, and let's just drop in some variables. We'll be calling our MySQL_database Spring_data with a user of Spring_user and a password of Spring_password, and then creating a root password of Spring_root. Okay, so making sure that the Docker service is started on your machine, let's go ahead and start up the server. And let's just verify that the container setup is all correct. Okay, and as we can see down here, our Tomcat server has started up on port 8080, so everything looks okay. Awesome. Let's go ahead and stop the server. And let's open our resources, source main resources application.properties file. And let's put in some basic property information. Okay, so we're going to define our server.port as 8080, just for fun. By default, it is always 8080. We're going to be playing with some of the logging levels, which will make it a lot easier to follow what's happening with our JWT token requests. So we first set logging.level.root to Warren, and then we can set logging.level.web, which is basically all the web components, to info. And then the logging level com.example, which is basically all of our objects, we'll set it to debug. Okay, and then we'll help out Hibernate by specifying spring.jpa.generate DDL to be true. And that's all we need for the moment. Okay, so let's go back into the root of our project and let's create a few folders. So in the root package of our server project, let's go ahead and create a few new packages that will be populating with source code throughout the rest of the work on this server. Let's create a config package, a controllers, a DTO, a filters, a models, a repositories, and a services. Let's go ahead and start with the models. We're going to be creating a user model, so let's call it user. And with the help of Lombok, we're going to be making use of data, builder, no args constructor, all args constructor. It's an entity, and we want to enable toString. And lastly, we're going to be specifying a table name of users. Okay, and we're going to be implementing the user details from Spring Security. So then we're going to have the ID annotation with a generated value of strategy equals generation type identity, which will be basically the ID of our user entity. Let's create a first name and a last name field. Let's create an email field along with a password. Then let's also create some timestamp fields created at and updated at. And then we'll look at role security. So our role enum doesn't exist yet. We'll add that next. And because we're implementing user details, there's a method here, Alt-Shift-Enter for IntelliJ, where it says implement methods. So all of these base methods that we need to implement are highlighted. Let's hit OK, and it will add it to the end of our object. So the get username is going to be the field that we want to use to be the quote-unquote username for the purposes of Spring Security. So for our example here, it is going to be the email field. So the email will be the username that users will use to log in. And for all of these return falses, just flip them to return true. So the account is non-expired, the account is non-locked, the account is credentials non-expired, and the account is enabled. So return true for all these. And then for this collection of get authorities, all we need to do is return a list of new simple granted authority role.name. Okay, and let's go ahead and quickly create the role enum. So let's create a new Java class. It'll be an enum, and we'll just call it role, which is in the same package, which is in the models package where we created the user. So we've got a public enum role, and all we have is a role admin and a role user. So the idea behind roles is that once we authenticate, then the server will also be able to authorize what we're able to do. So authentication is proving who you are, and then authorization is proving what can you access. So we'll have two levels of roles in this server setup. We're going to have an admin role and a user role. There will be certain endpoints that only users will be able to access, and other endpoints that only admin users will be able to access. Okay, let's make sure everything resolves okay back in our user. Looks like it does. Excellent. So let's go ahead and create our repository. We'll just create it as an interface and call it user repository. Within our repositories package, we'll be extending the JPA repository interface and making use of user and long. And let's just resolve this. And we'll be adding a access method in here where we will be find by email and passing in the email to this function, and it will return the user if it exists in the database. So let's jump up to our config package and let's create a PasswordConfig class. And all this is going to be doing is creating a Java bean to return our password encoder. So we'll use the configuration annotation and define it as a bean and public password encoder, return new bcrypt password encoder. Okay, so all that looks good. That's all we want to do for this. Okay, I've increased the font size a little bit. Hopefully that helps make it a little bit more legible. Okay, so let's move on back to the config folder and let's create and set up our SecurityConfig class. So let's call this one SecurityConfig. Okay, and it's also going to be a configuration annotation. we are going to be enabling web security. We are going to be enabling method security. And we'll be making use of the required args constructor annotation. Okay, so we're going to have a JWT Authentication Filter, which we'll be creating shortly. A private reference to that. We're going to have a private reference to our UserService to help with the authentication portion, which we'll also be creating shortly. And we've got our bean for our password encoder, which we'll need to make use of here in Spring Security. In the SecurityConfig, sorry. Okay, so first up, we're going to be creating another bean, and it will be returning a authentication provider. Authentication provider. So we're going to be creating a DAO authentication provider object, and we are going to be setting the user details service to our UserService, which we haven't yet created. Okay, we'll be calling it user details service within that service. It'll make sense once we set it up. Okay, and then we'll set our password encoder, auth provider, set password encoder to our password encoder bean. And then we'll be returning auth provider. So that's all we need from here. We're going to be creating another bean where we're going to be returning our authentication manager. Get authentication manager, and one of the parameters to this bean is going to be authentication configuration, and this bean will throw an exception, or it can throw an exception. And lastly, we're going to be setting up our security filter chain. The security filter chain is responsible for helping define what kind of endpoints we'll have available that Spring Security will then make available for us to actually make requests of. By default, Spring Security will lock down everything, every request to your server. So we have to configure the available endpoints to let Spring Security be aware of them. So it's going to be another bean, and we're going to be returning a security filter chain, which takes in a parameter of HTTP security, and it can also throw an exception. So I'll just throw as exception. Okay, so first off, we're going to disable CSRF. So we'll have CSRF, and then we'll make use of a Lambda function to disable it. Okay, next we're going to be setting up our session management. Session management, and make use of a Lambda function and set our session creation policy to be session creation policy .stateless. Next up, we're going to authorize HTTP requests. And then within this Lambda callback, we are going to define the endpoints that we're going to be authorizing. So let's use request matchers, and we'll be allowing HTTP method.post. And these will be post calls to the sign up and sign in endpoints. So /API v1 sign up and /API v1 sign in. And we're going to be permitting everyone. So there won't be any security around those two endpoints in terms of guarding requests, just because everyone needs to be able to access them in order to sign up and sign in. Okay, and then we're going to be defining another request matchers with the HTTP method get. And all I've done is I've made some TestController endpoints to verify that the role authorization is working okay. So we'll be using /API v1 /test /*. And then we'll be permitting everyone. So .permit all. And then after that, dot any request, and finally dot authenticated. And then let's close up this. And then we're going to finally define our authorized authentication provider to be our authentication provider bean. And then we're going to also add our filter, which will be our JWT authentication filter that we will create momentarily. And then we also need the username password authentication filter class to define what it is, what its base functionality is. Okay, let's go ahead and end that. And then finally, we'll return HTTP build. So with that out of the way, let's go ahead and look at creating both the user service as well as the authentication filter. So I think we'll start with the user service. So down in our services package, let's go ahead and create a new service, and we'll call it user service. And we'll make use of the service annotation and the required args constructor annotation. Okay, and then let's have a reference to the user repository. Okay, so first up, we're going to be making that user details service method that we mentioned back in the security config. So public user details service. And then we'll call the method user details service. And what we're going to be doing is return a new instance of the user details service, which is a Spring security core service that we need to provide an override for. And then let's go ahead and define that override. So making use of the override annotation, we're going to be making a method called public user details, load user by username, and we'll be passing in the username, which is going to be our email. So we're going to be returning the user repository, find by email, and then username, or else throw a new instance of an exception. So new username not found exception. Let's just call this username not found. Okay, we're also going to be creating a method called save, where we save a user to the database, well, to the repository, and we return the newly created record back out to the caller. So if new user dot get ID equals null, then we're going to be setting the set created at field to local date time now, and then new user set updated at to be local date time now, and then we're going to be returning user repository dot save. So everything looks good there. I think we've got everything we need to in the user service. So let's go into creating our JWT authentication filter. So back in our filters package, let's create a new class and just call it JWT Authentication Filter. Okay, and it is going to be a component. Make use of the component annotation, the required args constructor, and also the SLF for J annotation. And this just helps us to log events that we need to in the server to make sure that things are coming through the authentication filter. So they are optional. Once you get it running, you can take that out if you don't want any noise at all in your log files. So we're going to be extending the once per request filter. So this will run once per request to the server. Okay, so we're going to be having a reference to the JWT service, object, which we'll create, and another reference to the UserService, which we did just create. Okay, now each filter has to provide an override for a method called doFilterInternal. And this is where we accept the HTTP servlet request, as well as the HTTP servlet response, and the rest of the filter chain, which gets passed on through each filter in our server. Okay, so this throw a servlet exception and a IO exception. So if we go back to our diagram, let's magnify this a bit. So if we go back to our diagram, we can see here that the filter sits right here, where it pulls the JWT from the HTTP header of the request and then sends it through the rest of the server. So that's all we're going to do in our... Okay, so first we're going to pull our actual auth header. It'll be stored in the authorization header. And let's just create some variables to hold our JWT and payload here. So final string user email. So if the string is empty, or the string does not start with bearer, and that space is on purpose, so we need the space after bearer, then what we're going to do is we're going to call filter chain, which is any other filter in the server filter chain, and pass things off to their doFilter method. So request response, and then return. Okay, so next up, we are going to then extract the header from the JWT string from the auth header string. So we'll call substring 7, which is bearer with the space, and so then the rest of the string becomes our token. So let's go ahead and print that out with log.debug. And then we'll also extract the user email, which will be stored in the JWT string as well. So we'll pass that into our JWT service, extract the username from it, and return it back to our user email. So if our user email is not empty, and the security context holder get authentication also returns null, then we want to come in here and set our context to be our given username information, provided it exists in the database. So we'll make a call to the load by username method of that user details service. So UserService user details service load user by username, giving the user's email that we extracted. And then we'll be calling the JWT service method to validate the token, which we'll be creating after this. So if the token is valid, given the JWT string and the user details information, then let's make use of the debug statement and spit out the user details. And then what we need to do is create a security context. So security context equals security context holder create empty context. And then we want to also create a new token, a username password authentication token, which we'll call auth token. And that will be a new username password authentication token object with our user details object, null for credentials, and user details.getAuthorities, which is basically our roles. So either a role admin or role user. And then for the auth token, we are going to set the details. Let's go back here. So we're going to set the details, which will be a new instance of the web authentication details source, building the details from the request object. This stuff is not so important to understand every single step of this. I'm just trying to go through it to highlight what we're trying to do and what is sort of happening. So then we want to set our security context, the authentication of that to the auth token that we've just created. And then finally, we want to set the context of the security context holder to be context. And assuming everything goes okay, we want to then call filter chain do filter request response. And that should be it for our JWT filter. Okay, so before we go any further, there's a few libraries that we'll need to import into our project, which will be our JWT dependencies. So let's go ahead and open up our Pom.xml file. And let's navigate down to our dependencies section. And we're going to be adding three new dependencies. So usually just before the test dependencies here, I put in any new ones. Okay, so we're going to be making use of the io.json web token JWT-API package, the io.json web token JWT impl package, or dependency, sorry, and the io.json web token JWT Jackson dependency. And then we're also going to be making use of the commons lang3 package from the org apache.commons. And that's just to help with those string utils methods. So now let's go ahead and create the JWT service, okay, which will be a service. Make use of the service annotation, and we're going to be pulling a few new properties from our application.properties file, and we're going to be storing them in these variables here. We're going to be creating a new value called token.secret.key, which will store in this secret key string, and then a token expiration ms value, which is basically used to help us with signing our JWT token. So a secret key is something that you generate for each individual server. If you're making use of the code that's provided in this tutorial, then just make sure you generate your own token security key. And I will tell you I'll show you how to do that in just a few minutes. So next I'm just going to cut and paste a bunch of methods in here, which is used for creating the JWT token and also working with our claims, which is basically our email, in the generation of a new token. So I'll walk through these. First up, we've got a method called extract username, which will, if you pass in a token, it will then it'll extract the claim from that token of the subject claim of that token. So that's what JWT, here, let's go back to our diagram here. The claims is a method that JWT uses in our payload. So claims are basically just the notes I have are claims include things like expiration time and subject. So an example could be our name, which is admin at admin.com. So basically an email address, and then an expiration time. So basically how long is this token good for? Okay, then we've got a generate token method, which will take our user details as input, and then it will return a new generated token from down here. So here's another method that we'll be calling, which is the token valid? And all we're doing here is passing in a token that we've extracted from the auth header, and then supplying our user details object, and then seeing if the given token is valid. And then here's some methods to extract the claim. We don't have to really go through line by line each of these methods, because once you've got this working, then you really never need to go back to them. So here's our generate token function. And so what we're going to do here is make use of the JWTS object, which is part of the packages that we just finished setting up in the Pom.xml. And it's using a builder. So we're going to be setting our claims of our subject, which is our username, so basically the email. We're going to be creating a issued at time, which is the current time in milliseconds. And then we're going to be also setting an expiration of a new date time of a new date of the current millisecond time along with our expiration ms variable. And then we're going to sign it with the HS256 signature algorithm. And then compact that together. That's really the meat of this whole service. And then there's a few other methods here to check if things are expired, extract our expiration time from our token, extract all of our claims from the given token, and then finally so this method just basically creates a signing key that we return in that payload of the JWT, making use of the JWT secret key variable from our Application.Properties file, which we'll go ahead and create right now. So this is everything I wanted to do here. So back in our Application.Properties file, at the bottom here, let's add in our token.expirationMS variable, which I've set it to 3,600,000 milliseconds, which is 1 hour. Okay, and then we have that other variable called token key. And so one way you can generate a new token is, I've put it in the comments here. You can type this node-e console log require crypto random bytes 32 to string hex. So if you have Node installed on your system, you can just cut and paste this into a console. So let's do that now. Let's copy. Okay, so let's paste it here. We've got it in our console. And it returns this number. Just cut token.secret.key equals blah. And there we go. So just every time you want to regenerate a new key, just cut and paste this JWT, this node command to do that. Okay, so we're making progress. So in our authentication service, so we're going to be creating a new service here called Authentication Service. And this is just responsible for authenticating our given username and password. Okay. So it is a service annotation, and we'll be using the required args constructor. And let's go ahead and cut and paste what we're going to be needing. Okay, so we've got a reference to the user repository, the user service, the password encoder bean, the JWT service, and the authentication manager that we defined in the security config. Okay, and so we are going to be creating our sign up and sign in service calls here. So we are going to be responding with a JWT authentication response DTO that we'll be creating shortly here. And we'll be allowing a sign up request DTO called request. So we'll be making use of the user builder. And so what we're going to do is specify a user, make use of the builder method, then create our first name, last name, set the email to be the email from the request, set the password with the help of encoding the password field of our request object, and then we'll be by default defining it as a user role user. Then we'll be saving that user in the user service. We'll generate a new token with the help of the JWT service, and then finally return a JWT authentication response DTO with that token. Okay, and then let's go through the sign-in request here, the sign-in service call here. We'll be returning a JWT authentication response DTO, and we'll be accepting a sign-in request DTO, which we'll go through shortly here. So with the help of the authentication manager, we're going to be authenticating. We're going to call the authenticate, passing in a new user password authentication token composed of the email and password that we send in. We are going to look in the user repository for the email from our request, or else throw an exception. Finally, we're going to generate a token from the given user and then respond back to the caller with a JWT authentication response payload. So let's take a look at those DTO objects right now. Maybe that'll help clear things up. So in the DTO package, let's create a new class calling it JWT Authentication Response. And this is all we need. It's a data object. We'll be making use of the builder annotation, the no-args, and all args constructor annotations. So we've called it JWT Authentication Response, and all it has as a member is the token string. So then let's create the sign in request DTO, and it will look very, very similar. So we'll be making use of the data annotation, the builder, the no-args constructor, the all-args constructor, and all we need to use for our signing in is the email and password. Okay, and then sign up request. So for sign up request, all we need to make use of is the data annotation, builder again, no-args and all-args constructor annotations. And all we need to do to sign up is just pull in the first name, last name, and the email and password of the new user. Okay, so we're getting pretty far here. We're just about finished. Let's set some seed data in our database so that we have an admin user that we can make use of during testing. So back in our config package here, let's create a class called seed data config. And I'm just going to cut and paste my class here, and I'll go through it. So it is a component using the required args constructor, and again, SLF for J just for logging. So we're going to be implementing the command line runner. And we'll have references to our user repository and our user service, along with the password encoder. In the run method, we'll be getting a count of the records in the user repository. And if there's no records, then it means we can create a new user. So we're going to set up the builder, set a first name, last name of admin, set our email to be admin@admin.com, and then use the password encoder to encode password as our password. And for the role, we want to set our role to be an admin. Then we call the build method, and then we save it with the help of our user service, and then finally we can spit it out in log file. Okay, so far so good. Okay, so now let's go ahead and look at our authentication controller. So in our controllers package, just create a new controller called Authentication Controller. And I'm going to cut and paste my code into here. Okay, so it's going to be a REST controller with a request mapping of /API/v1, along with making use of the required args constructor annotation. So we're going to have a handle, we're going to have an instance of the authentication service, and then we're going to be accepting a post call to the sign up endpoint, and then returning the authentication response. Okay, and then similarly, we have another post mapping defined for signing in, and we're going to be allowing a sign in request DTO in the request body, and then we're going to be calling the authentication service sign in of the request, and then returning a JWT authentication response DTO as the response. And so there's one thing left to create, and that is some test endpoints. This will help us demonstrate the use of role authorization to determine what our user is allowed to access. So back in our controllers, create a new controller called TestController. At least that's what I called it. So TestController. In the interest of time, I will again cut and paste my code, and let's walk through it now. So it is a REST controller. We're using a request mapping of /API/v1/test. And so we've got a mapping here called /anon, and this is basically, it'll return a string saying everyone can see this. So you won't need it's not governed by any role security. Then we've got a get mapping of /users, and we use this pre-authorize annotation here to determine does our security context holder have the role of user. So does the currently authenticated user have the role of user? And for this one, all we're returning is a string saying only users can see this. So if we have an admin account, it won't be able to see this. And then finally, we have a get mapping for /admins, which uses the pre-authorize of has role admin. So is the currently authenticated account an admin role? And if so, then just return only admins can see this text. Okay, I think that's everything. Let's start everything up and go from there. Okay, so as you can see, the server started up. We've got our log message, created the admin user, and that was the user in that seed data config. So let's go into our database. So HTTP localhost 8081, and our login was spring_user and spring_password. And so we've got our Spring Data table here, or Spring Data database here. We've got our users table. And if we go in, we can see that we've got our admin user created here using the role of admin. Cool. This is really a good sign. So then let's open Postman. So Postman is a free tool to help you deal with APIs. So the first thing we're going to do is create the signup request. So let's hit the plus sign here and change this to post. And we are going to be calling HTTP localhost 8080. And then it was /API/v1/API/v1/signup. Okay, we don't need to send any headers with this one. And our body, we're going to set to raw and then JSON. And then remember that we need a first name. So first name, we'll just call it user. Oh yeah, it's not valid, JSON there. Okay, so first name user and last name user. Why not? And then email, we'll call it user@user.com. And then password will just be password. Nice and secure. Okay, so then if we hit send, we see a 200 OK response, which is a really great sign. And in the response, we've got our new token. So we can ignore that token for now. We can't use it in the next request because the next request is going to be signing in. So we're going to sign in using the user that we just created. Oh, before we do that, let's verify that we can hit the anonymous endpoint of our TestController. So let's hit the plus there and we'll use a get, and it will be to HTTP localhost 8080/API/v1/test and then anon. And there's no parameters. We don't need to send anything with that. And so we get a 200 response and the text, everyone can see this. So this is all really great sign. Okay, so we have our sign up request demo here. So let's now sign in. So hit plus again and let's create another post. And we are going to be going to HTTP localhost 8080/API v1 sign in. And then for our body, again, we'll be using the raw JSON. And we will be using the email of user@user.com and password of password. So if we go ahead and hit send, we see a 200 OK, and now we have a token that we can use in the next request. So let's keep note of this here. And then let's create another GET request. So this is a GET, and we'll be going to localhost 8080/API/v1/test, and then this is going to be to the users. So we should access it because we are a user. Our role is users. So let's send it now. We won't put our key in the header yet. Let's send it without the header and see what happens. Okay, so we get a 403 forbidden, which is a good sign, a really good sign. So now let's go to our headers, let's go to our auth, and let's select bearer token. And then for the string here, it automatically fills one in, but let's just make sure it's the one that we received from the sign in payload here. So cut and paste that into our token here. And then let's try sending it again. Okay, we get a 200 OK response, and only users can see this. Okay, now we have a, okay, this is really good. Okay, so we've got our token set up in the auth header. So let's try and hit the admin's endpoint and see what happens. Okay, our current security context is the user. So let's see what happens when we try and get the admin. Okay, so we see a 403 forbidden, which is exactly what we want to see. So now let's go back and let's log in. Okay, let's log in with our admin account. So it was admin@admin.com. We get a 200 OK response and then a new token to play with. So let's cut that. And let's get our admins and just make sure to update the token with the new token that we received just now. And we see the string only admins can see this, sorry, which is really fantastic, really good. And again, let's try and get the user's endpoint with our admin token. And we're forbidden. We can't get it. So this is all really, really good stuff. Let's double check our database. Since we can log in, we know that our database is okay, but I just want to show it anyway. So let's just go into users again. So we see here that we've got our admin@admin and all of our information for the admin, and then our user, which is our signed up user, that is a role_user. So there we go. We did it, everyone. That was really exciting. I had a lot of fun putting this together. Hopefully my explanations were clear on working with JWT on the server for Java Spring Boot. Like I said in the intro, I'm going to be planning out some videos on making use of the JWT server with client-side libraries such as React or Angular, but make sure you put your preference in the comments of this video down below to help me prioritize what to kind of put out first. But hopefully you had a great time going through this video. Be sure to grab the source code from the description, and we'll see you in the next one, everyone. Peace.